Hey guys, in this video I'm going to go through an example of an application question related to graphing polynomials, and hopefully in the process helping you better prepare for your SAC 1. Now this question is not too difficult, but still an important one testing your understanding on the basic shape of a quartic graph. I suggest that you pause the video and see if you can attempt each part of this question before watching the solution, or you can just double check your answers. So let's get into it. The diagram at right shows a main road passing through O, A, C and E. The road crosses a river at point O and 3 kilometers further along the road at point C. Between O and C, the furthest the river is from the road is 8.54 kilometers at a point D, 2.25 kilometers east of a north-south line through O. The point A is 1 kilometer east of point O. If point O is taken as the origin and the road as the x-axis, then the path of the river can be modeled by a quartic function as shown in blue. Part A. Give the coordinates of C and D. If O is the origin and the road as the x-axis, then we can draw a vertical line and call this the y-axis and label the road as the x-axis. We're told that the point C is 3 kilometers further away from O. This means the coordinates of the point C is going to be 3, 0. And so for part A, the coordinate of C is going to be 3, 0. The point D is the furthest the river is from the road, and we're told that this distance is 8.54 kilometers and 2.25 kilometers east of the north-south line, which is the y-axis. And so the coordinates of the point D is going to be 2.25 and then minus 8.54, since this is below the x-axis. And so the coordinates of D is 2.25 and minus 8.54. Part B. Find the rule for the quartic function f of x. Looking at the graph of the quartic function, we can see there's two x-intercepts. One at the origin where x is equal to 0 and one when x is equal to 3. At the origin, we're going to have a cubed factor. And we know this because there's a point of inflection at this point. And when x is equal to 3, we have a linear factor. And so, in a general factorized form, we can write the equation f of x is equal to a, some dilation factor, times x minus 0 cubed, which is going to be x cubed, times x minus 3. Cleaning this up, this is just ax cubed times x minus 3. We now need to work out the value of a. To do this, we need a point on the graph. And we know that the point D has the coordinates 2.25 and minus 8.54. And so f of 2.25 is going to equal minus 8.54. Subbing this into the rule, we can solve for the value of a. And it's going to be quicker using the calculator. Starting by defining the function f of x. And now setting up the equation, we can solve for a. Correct to 2 decimal places, we can see that the value of a is going to be 1. And so therefore, the rule of f of x is going to be x cubed times x minus 3. Part C. How far is the river from the main road along the track AB? To find how far the river is from the main road, we need to work out the distance of the track AB. Being a vertical line, we just need to work out the y-coordinate of the point B. We're told that the point A is 1 kilometer east of the point O. And the point B is directly below the point A. And so this means that the x-coordinate of the point B is going to be 1. And so its y-coordinate is going to be f of 1. We know that f of x is equal to x cubed times x minus 3. And so f of 1 is going to be 1 times 1 minus 3, which is equal to minus 2. And so therefore, the distance of AB is going to be 2 kilometers. Part D. A canoeing race of at least 17 kilometers in length along the river is being organized. It is suggested that the race could start at O and finish at C. Is this course satisfactory? Why? For the canoeing race to be satisfactory, we need the distance of the river from 0 to D and then from D to C to be at least 17 kilometers. Now we can't calculate the actual distance of the river, but we can calculate the distance of a straight line from O to D and then from D to C. which is going to give us a good estimate of the distance of the river from O to C. Now we know that the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. To work out the distance of the line OD, we need the coordinates of the point O, which is 0, 0, and the point D, which is 2.25 and minus 8.54. And so if we let this be x1, y1, and this x2, y2, then the distance OD is going to be the square root of 0 minus 2.25, which is minus 2.25 and then squared, plus 0 minus 8.54, which is plus 8.54, all squared. And so setting this up in the calculator, we can work out this distance. And so this is equal to 8.83 kilometers. And now to work out the distance of the line DC, we're going to need to use the coordinates of the point D, which is 2.25 minus 8.54, and the coordinates of the point C, which is 3, 0. And so again, if we call this x1 and y1, and this one x2 and y2, using the distance formula, the distance of the line DC is going to be the square root of 2.25 minus 3 squared plus minus 8.54 minus 0, which is going to be minus 8.54 squared. And so setting this up in the calculator, we can work out this distance. And so this is equal to 8.57 kilometers. And so the total distance is going to be the sum of these two distances. Which is 17.4 kilometers. But the actual distance of the river from O to D and then from D to C is going to be more than 17.4 kilometers. And so because we want at least 17 kilometers, then the distance from O to C is more than 17.4 kilometers, then therefore we could say that yes, this course is satisfactory. And that's it for this question. Comment below and let me know if it was any helpful. Good luck, and I'll see you guys in the next video.